Key concept, line tangent to a parabola. So we're going to do this interesting math problem where we find the equation for a tangent line. So this right here would be my tangent line. So if you look at my parabola, the tangent line is touching the parabola at just point P. So basically it's touching the parabola on only one point and then it's bouncing off again. So in order to find the equation for that line, we really need 2 points. So we have 1 point because we're given P, the point on the parabola, but then we need a second point as well. So we're going to use this property where if we look at our focus is equidistant to a random point on our axis of symmetry as it is to this point P on our parabola. So we're going to use this in order to find the equation for that tangent line. So let's go ahead and try an example. So we are given a parabola. I always like to just sketch a parabola out. I could put this into our new form, but I don't need to graph it. So I'm going to go ahead and graph it first. I will need to put it in the new form to find the focus, however. Remember, everything is equidistant from that focus. So here I am at 0, -2. That's my vertex. It's up 1 and then 3 on both sides. So that 1, 3, 5, 7 still works. And we want the tangent line at this point, 2, 2. That means we're looking for this equation here that just touches the parabola at 2, 2, and then bounces off. So we have 1 point on our parabola, but remember we need 2. We need the second point that's on our axis of symmetry. And so I really need to figure out my focus. We know that we're trying to figure out, if we look at our focus is equidistant to that point P on our parabola and a random point on our axis of symmetry. I'm just going to call it A. We know the focus is equidistant to both of those and that A and P are both on that tangent line. So if we have A, we have a second point, and if we have 2 points, we're able to write the equation for a line. So let's go ahead and see if we can figure out the focus. So right now I have my equation for my parabola, but it's not in the right form so that I can really look at what the focus is going to be, like what that P distance is, right? I've got to be able to figure out 4P. So I'm going to put, what do I want to do? I want my 2 on my other side. So I have y plus 2 equals x squared. And then really this whole thing is backwards. And since we're doing something new, I'm going to flip it around. Normally we don't really like to swap sides of an equation, but there we go. And then I would just put a 1 in front of the y plus 2. So now I can see that my vertex would be like the 0, -2, which I have. And I know that 4p is equal to 1. And so p is equal to 1/4. So I know that my focus is going to be 1/4 of a unit up from my vertex. And so my focus is going to be at 0, comma, let's see, I'm at -2, but I'm adding 1/4 of a unit. So my focus will be at 0, comma, -1 3/4. All right, so once I have found that, and you know what, let's do improper fractions because those are going to work better in our equation. Now I know this focus is going to be equidistant to point P on my line, and also that random point on my axis of symmetry that I really want to find. So in order to figure out that random point, I really need to know what the distance is first. So did not mean to make that mark over there. Let's go ahead and scroll up. Let's go scroll up. And so my second step, so my first step was finding the focus. My second step is going to be the distance from the focus to P. I've got to figure out what that distance is so I can make sure they're equidistant. So F to P. So distance formula, D equals square root of x sub 2 minus x sub 1, that quantity squared, plus the quantity y sub 2 minus y sub 1 squared. And let's see, P is at, remember, 2, 2. My focus is at 0, -7/4. So I'm going to go ahead and just substitute everything. So this will be 2 minus 0 quantity squared plus 2 minus -7/4 squared. So let's go ahead and simplify here. 2 minus 0 would just be 2 squared. And then here I'm going to have plus. I'm just going to make this 2 7/4. And then in order to work with that, I now want to go ahead and make it into an improper fraction. So I've got, get my pen back. 2 squared is 4. And now I'm going to go ahead and make this, let's see, 2 times 4 is 8, plus 7 would be 15/4, and I still have to square that. So let's see, this is going to be 4 plus 225/16. So I need to make the 4 into 16ths, so that's going to be square root of 64/16. So I just multiplied the top and bottom by 4 to get a common denominator, plus 225/16 means I am going to have a distance of 289/16, and I've got to take the square root of that. So square root of the top and bottom is now going to be 17/4. So now that I've got my distance, I know that my distance from F to P is the same as from F to that imaginary A point that I want somewhere on my axis of symmetry. That's why I'm just calling it A. So I need to figure out that other point. Remember, I need to have 2 points on a line in order to write an equation. And I know that P is just one of the points on my line. The other one is going to be this point down here that we're going to call A, that's on my axis of symmetry. So if it's on the axis of symmetry, I already know that the X value is 0, but I need to figure out the Y coordinate. So that's what I'm going to do now, is I'm going to figure out A. I'm going to find coordinates of A, which I'm going to call that point on my axis of symmetry. So that'll be 0, comma. So I know that from F down to A is going to be 17/4 of a unit. So negative 7/4 plus 17/4. Oh, wait a minute, I'm subtracting because this is going down. So minus 17/4 because we're going further down on that, on the y-axis there. So it'll be 0, comma, negative 24/4, which is 0, comma, negative 6. So it's really satisfying now to get an integer out of that. So my last step now is to actually write an equation for the line. Equation, that's an N for the line. So I have the 2 points to work with. I have that point I'm calling A because it's my axis on my axis of symmetry, 0, negative 6. The other point is the one I was given on the parabola, 2, 2. So now I just write an equation. It turns out I already have a y-intercept. 0, negative 6 is my y-intercept. So I could do y equals mx plus b pretty easily, but I do need a slope. So my slope is going to be 2 minus negative 6 over 2 minus 0, which is going to be 8/2. So my slope is 4. And because I know my y-intercept, because I already have 0, negative 6, it's a point on my y-axis, is negative 6. So y equals 4x minus 6. And I am all set. So I've got an equation for my tangent line. So again, just to do kind of a quick review of steps, we used that property we learned on the other page where my focus is equidistant. I'm putting my focus completely in the wrong spot. It is not up here, but it's basically equidistant to this point on the parabola as it is to that point on my axis of symmetry. So I found my focus. I did this distance. Once I knew that distance, I knew that my focus to that point was the same. So I could find that point. Once I had that point in P, I could write an equation of the line. So this is it for example 5 on our notes.